Well, Michaela, do you have some questions?
Hold on. Let me pull up my homepage real quick because I had a question.
Okay, good.
So I just needed a little assistance with the real numbers, the first task on my agenda.
Uh-huh.
So I just
So
needed.
what's your question? Yeah, go ahead.
I just don't understand it. Like, I just need a little more assistance with it.
Okay. So there's different kinds of numbers. Like real numbers are made up of rational numbers and whole numbers and integers. If you, the, oh, Latoya, are you back? Can you hear? So like this set of numbers is called natural numbers. Can you see my writing?
Yes.
Yes, okay. So 1, 2, 3, 4, and on forever. Those are called natural numbers. If you add in a zero, 1, 2, 3, 4, and on, those are called whole numbers. I always remember it because zero kind of looks like a whole. It starts with a zero. If you add in the negative numbers like this, -4, -3, -2, -1, 0, 1, 2, 3, and on forever, and on forever in that direction. Those are called integers. And then the one that's even more interesting is you add in all the fractions and decimals, all the in-betweens. Those are called real numbers. If you're looking at, like, a lot of times mathematicians look at it on a number line. See, the arrows mean it keeps on going. So because I can't write it forever. So these that I have marked are the integers. They're the negative numbers and the whole numbers. But there's all sorts of numbers in between here. Like between 0 and 1, there's 0.5 right there. Or there's 0.9 right there. Or back this way, I could have -1.5, or going this way, I could have positive 2.8. There's lots. I could list them forever. There's lots and lots of, oops, hold on a second. I'm going to get this back. There we go. So there's lots of numbers in between all of these integers. Those are called real numbers. So this list is integers. I'm spelling it wrong. INTEGERS. This list is all the real numbers. Jeez, I can't spell anything today. Okay. And then there's the numbers that are not the real number, or rational numbers. This are numbers like pi. Those are the weirdo ones that are like decimals, 3.141, and it keeps on going and going. Those kind of numbers are called irrational numbers.
Okay.
Does that help some, Michaela?
Yeah, I just needed.
So what's
question.
what's the question that you're stuck on?
Let me just pull it up.
Okay.
The question that I'm stuck on is a shop teacher has 4 sockets in a drawer. They are labeled 5/16 inch, 3/8 inch, 13/32 inch, and 15/32 inch. Which one has the smallest measurement?
Oh, so Are these the numbers? 5/16, 3/8, 13 30-seconds, and 15 30-seconds?
Yes.
Yes. Okay. To change a fraction to a decimal, you have to divide. So you take the top number and you divide by the bottom number. And it's probably easier to compare all these if I change them to a decimal. So I'm going to take 5/16 and go 5 divide by 16. It's 0.3125. I'll write it down right beneath here. 0.3125. And 3/8, if I change that to a decimal, the top divided by the bottom, 3 divided by 8, that's 0.375. 13 30-seconds, 13 divided by 32 is 0.40625. And the last one, 15 30-seconds. 15 divided by 32 is 0.46875. Geez. And the question is asking you for the smallest one.
Yes.
So when you look at these decimals, this one's the biggest. Actually, they're right in order. This one's the biggest, then this one, then this one. This is the smallest one. 5/16 is the smallest one.
Okay.
Think about, like, if you drop off all the rest of the decimals, think about pennies. This is like 46 cents. This is like 40 cents. This is like 37 cents. This is like 31 cents.
That makes it so much easier.
So that's the one that's the smallest. Is there another one that's hard?
Let me go check.
Okay.
I have a problem ordering them from least to greatest or from greatest to least. So if you could help me with number 7 on my assignment, it's a bait and tackle shop has fishing lures in the following weights. 5/8.
Okay, what are the weights? Because
9/16, 1/4, and 3/8.
Okay, so we're going to do the same thing. We want to change them to decimals.
Okay.
So I'll go 5 divided by 8. Hi, somebody else joined us. Can you hear us? 5 divided by 8 is 0.625. So this one is 0.625. Then 9/16, 9 divided by 16, that's 0.5625. 1/4, I bet you know that one in your head. Think about money again. 1/4 of a dollar. 1 divided by 4, 0.25. And 3/8, 3 divided by 8, 0.375. Okay, now what do the directions ask you to do? Are you supposed to go from least to greatest?
Yes.
Okay, so when you look at these, again, think about pennies. That's easy for me. This is like 62 cents, 56 cents, 25 cents, and 37 cents. This one's for sure the smallest, right?
Yes.
So that one's the very smallest. Which one comes next?
3/8.
Yep, then this one. This one's the second, I don't know how to mark it, the second smallest. So I'll put this one first. Here's the 1/4. That's the smallest of all. Then the 3/8. Okay, so we used up this one. Then it's got to be this one, right?
Yes.
Less than 9/16. And that's less than, that's the biggest of all, 5/8. So smallest to biggest, it goes in that order. That symbol is a less than symbol.
That just cleared up a whole lot because I was over here confused.
Good. Good. It's with fractions, if you've got a calculator in your hand, it's probably easiest to change them to a decimal to compare them. You can also get common denominators, but most students find that more work. If you don't have a calculator handy, that's probably the best way to go.
Okay. Well, thank you.
You're very welcome. Have you already done the adding and subtracting
Yes.
with fractions? Yes? Okay, good. Good for you. Hey, does somebody else have a question? Michaela, I'm glad I was helpful. I don't know. Hello? Anybody else have a question? Yeah. Any other questions? Well, then I'm going to go and do a few more practice fraction problems. When you add and subtract fractions, you have to get a common denominator. So if you have something like this, 3/4 plus 2/3, and you're going to add those together, you need to get a common denominator. A common denominator for 4 and 3 is, oops, bouncing around, 12. A lot of times you can just multiply them together to get the common denominator. Sometimes there's a smaller one, but that will always work. Okay? To change 4 into 12, you have to multiply by 3. So you multiply the top and the bottom of this fraction by 3. It becomes 9/12. To change 3 into 12ths, you have to multiply by 4. So you multiply the top and the bottom by 4. It becomes 8/12. Now that they're both 12ths, I can add those together. 9/12 and 8/12. That's 17/12. You can leave it like that, or you can go 12 goes into 17 one time. There's a remainder of 5. So it's 17/12. Or if you like the mixed number, it's 1 5/12. And there's the answer. When you subtract with fractions, it's real similar. You have to get a common denominator. If you have 1/2 minus 3/4, to do that subtracting, I have to have a common denominator. The common denominator for 2 and 4 is 4. Okay. 2 goes into 4 2 times, so I'm going to multiply the top and bottom by 2. 2 times 1 is 2. 2 times 2 is 4. That's good. 4 goes into 4 once. I'm going to multiply top and bottom by 1. That's not going to make any difference, is it? 3/4 is 3/4. Now I can do this subtracting. 2/4 minus 3/4. 2 minus 3, that's -1/4. They don't always turn out nice whole numbers. In fact, in algebra, a lot of times you get negative numbers. Here's another example of adding and subtracting fractions. If I have 5/6 plus 1/2, the common denominator for 6 and 2 is 6. So I'm going to change everything into sixths. This fraction, I don't have to change it all. Multiply top and bottom by 6 or by 1. Doesn't change anything. 5/6. This fraction, I'm going to multiply top and bottom by 3 to make 6 on the bottom. That's 1 times 3 is 3. 2 times 3 is 6. Now I can add those together since they have a common denominator. 5/6 plus 3/6. That's 8/6. 8/6 reduces. Notice the top and bottom are both even. Divide out 2, you get 4. Divide out 2, you get 3. There's my answer. 4/3. Or if you like, you can go 3 goes into 4 one time with 1 remainder. 1 1/3. Either one of those are okay for the answer. Most students just prefer leaving it 4/3. When you multiply and divide with fractions, it's even easier. You just multiply across the top and you multiply across the bottom to multiply fractions. If you have 4/5 times 9/10, multiply across the top. 4 times 9 is 36. 5 times 10 is 50. There's the answer, 36/50. Sometimes you have to reduce your answer. To reduce, check and see if the top and bottom divide by 2 or by 3 or by 5. 36 and 50 are both even numbers. They'll divide by 2. 2 goes into 36 18 times. 2 goes into 50 25 times. Well, let me check 18/25. The top's even, but the bottom's not. 3 doesn't go into 25. 5 doesn't go into 18. I think that's the answer, 18/25. When you divide with fractions, it's the same, but there's one more step. If you have something like this, 2/3 divided by 5/9. When you have a division, it's the same as multiplying by the reciprocal. The first fraction stays the same, the divide becomes times, and the second fraction you turn upside down. You want the reciprocal. The reciprocal is 9/5. See how that fraction just flipped upside down? The first fraction stays the same, the divide becomes multiply, the second fraction gets turned upside down. Now it's easy to do. 2 times 9 is 18. 3 times 5 is 15. And I'm going to reduce the answer. Look at 18 and 15. The bottom's not even, so 2 won't divide into them. But 3 goes into both top and bottom. If I divide 3 into the top, I get 6. If I divide 3 into the bottom, I get 5. There's my answer, 6/5. Or if you like, that's 1 1/5. When you divide with fractions, you multiply by the reciprocal. So if I have, here's a hard one, 12 divided by -1/3. The first number stays the same, 12 times, turn the second one upside down, -3/1. This is 12/1. A whole number you can always put over 1. Notice reciprocal keeps the same sign. So when I multiply up here, I get -36/1. That's easy. That's just -36. Okay. Let's see. When you are ordering fractions, change them to a decimal, and then you can put them in order. If you want to write these in order from least to greatest, say I have 3/5 and 1/2 and 2/3 and 3/8. To put those in order, you write the decimal for them. 3/5, 3 divided by 5. It's always top divided by the bottom. That's 0.6. 1/2, everybody can do that in their head. 1 divided by 2, 1/2 is 0.5. That's 0.5. 2/3, that's an interesting one. 2 divided by 3. It's one of those repeating decimals, 0.6666. I'll just put a bar over it to show that. 0.666 repeating. And 3/8, 3 divided by 8, that's 0.375. If the directions say to write these in order from least to greatest, the smallest one is this one. I like to think about money, like 60 cents, 50 cents. This one's 66 cents. That one's 37 cents. The very smallest one is 1/2. This one. The next smallest is this one, 3/8. Then this one, 3/5. And the largest one is 2/3. So to compare fractions, you can get a common denominator and compare them all that way. Or if you've got a calculator handy, change them to a decimal, top divided by the bottom, and then you can compare them that way. Anybody have a specific question? Okay, well, we can look at some sets of numbers too. That's another common question people have. The natural numbers. Sometimes they're called the counting numbers. They're 1, 2, 3, 4, all of those numbers. Like if I were counting these pieces of paper in my stack here, I'd start with 1, 2, 3. I wouldn't count 1, 2, 2.5, 3. There's no halves, there's no decimals. It's just those numbers. The whole numbers are similar. It starts with 0, 0, 1, 2, 3, and on and on and on. So whole numbers start off with 0. It kind of looks like a whole. Integers have negative numbers and all the whole numbers. Actually, the definition is all the whole numbers and their opposites. So it goes forever in the negative direction too. -3, -2, -1, 0, 1, 2, 3, dot, dot, dot. So for example, -56 is an integer, or 257, that's way this way, is an integer, but not any of the fractions or decimals, not any of the in-betweens.
So would
Rational,
1.5 be considered an irrational number?
yes, 1.5 is a rational number. Rational numbers are all of these, it's everything above here too, but it's also the decimals and the fractions. And the best way to show that is on a number line, because I can't possibly list them all. But rational numbers are everything on the number line here. It's all these in-betweens too, like this one right here, 1/2, or this one right here, 1.9, or this one right here, -1.8. It's all, and I could list them forever. I could keep finding more and more in-betweens. Those are all the rational numbers, including the 1s and the 2s and the 3s. The whole numbers are rational as well. And then irrational numbers are really weird numbers. When you take a geometry class, you'll talk about the number pi. If I grab my calculator here and put pi in, See, it's one of those weirdo, big old long decimals. It doesn't repeat a pattern. It just keeps on going. In fact, no mathematician's ever found an end to pi. That's an irrational number. Irrational numbers, you just don't see them very often. But all of these kind of build, except for these irrational. Rationals are made up of integers and whole numbers and natural numbers. Integers are whole numbers and natural numbers. Whole numbers are the natural numbers. And irrational numbers are just weirdo ones. Does that help? So when you're looking at numbers like on the work, if they give you something like this, -12, and they ask you which ones of these it belongs to, well, -12 is rational, and it is an integer. It's not a whole number or a natural number. But this is rational and an integer. And I think some of those questions, they let you pick more than one thing. That's hard for students. I think you can only pick one answer, but you can pick more than one. Okay, Michaela, you have any other questions?
No, that about covers everything.
I'm glad. Good. Okay, well, I am about to sign off then. If you don't have any other questions, Michaela.
Okay.
If you have more, you can text me. My phone